Have you ever pondered the nature of time and reality? What if we told you that time isn't linear as we perceive it to be? Time, as we understand it, is a constant forward march, a relentless river carrying us from the past, through the present, and into the future. But what if this isn't the full story? Enter the concept of time loops, a fascinating idea that challenges our everyday perception of time. Picture this. Instead of flowing one way, time bends back upon itself, creating a continuous loop. This implies a non-linear understanding of time, a reality where past, present, and future coexist and interact in ways beyond our usual comprehension. This concept, mind-bending as it may be, has been the subject of intense study and speculation in the realms of philosophy, science, and even pop culture. Today we're going to delve into 3 intriguing theories about time loops that might just alter your perception of time and reality. Imagine waking up to the same day over and over again. Sounds like a movie plot, doesn't it? Well, this is precisely what we call the Groundhog Day scenario, where time gets stuck in a seemingly endless loop, forcing us to relive the same events continuously. While this concept might seem like a quirky Hollywood invention, it actually has deep roots in philosophy and theoretical physics. The idea of eternal recurrence, a term coined by the philosopher Friedrich Nietzsche, suggests that all events have already happened and will continue to happen over and over again for all eternity. This concept underpins the Groundhog Day scenario, painting a picture of time as a wheel that keeps turning, never moving forward or backward, but always returning to the same point. However, the implications of this theory go far beyond a simple reiteration of moments. If time is indeed cyclic, then our understanding of causality, the relationship between cause and effect, could be fundamentally challenged. Normally, we think of the past as a chain of events that have caused the present and will shape the future. But in a Groundhog Day scenario, there is no past, present, or future. Instead, all moments exist simultaneously in a constant loop. This theory could also have profound implications for our sense of free will and morality. If all actions are destined to be repeated infinitely, does that mean we lack free will? And if our actions have no lasting consequences, what does that mean for our moral responsibilities? These are the questions that the Groundhog Day scenario forces us to confront. Although it might seem far-fetched, it is a powerful tool for questioning our most fundamental assumptions about time, reality, and our place within it. In this theory, the past, present, and future are not distinct, but rather they exist simultaneously in a constant loop. Now let's jump into the realm of quantum physics. What if time could be in 2 places at once? In the world of the tiny and the incredibly fast, things get a little weird. Quantum physics, the science that describes the behavior of particles at the smallest scales, introduces us to a concept called superposition. This is the idea that a particle can exist in multiple states at once, only committing to one when it's observed. Now let's apply this strange concept to time. It's a bit mind-bending, but bear with me. According to the theory of quantum superposition, time, like a quantum particle, could exist in multiple states simultaneously. It's as if time were a book, and each moment a page. Instead of reading one page after another in a linear sequence, imagine being able to read multiple pages at once. Each page represents a different state of time, and we exist on all of them simultaneously. It's only when we observe time, when we become aware of a specific moment, that we commit to a single page. So, what does this mean for our understanding of time loops and reality? Well, if time can exist in a multitude of states, then the concept of a loop becomes less rigid. Rather than being stuck on a single repeating track, we can potentially exist in a superposition of multiple loops, each representing a different state of time. This theory is still very much in the realm of speculation and thought experiments. It's a radical departure from our everyday experience of time. But it's a testament to the power of quantum physics that it can challenge our most basic assumptions and open up new, unexplored possibilities. So, if you've ever felt like you're doing the same thing over and over again, maybe it's not just a feeling. Maybe you're experiencing a superposition of time loops, each slightly different from the other. This theory challenges our understanding of time as a single flowing entity, suggesting instead that it can exist in a multitude of states. What if there are countless versions of you, living out different timelines in parallel universes? This is the premise of the multiverse theory, our third exploration into the mysteries of time loops. The multiverse theory posits that our universe is just one of an infinite number of universes, each with its own laws of physics, its own history, its own timeline. This means that each universe within the multiverse could have its own unique time loop. Imagine, if you will, a version of you in a universe where time moves backwards, or another where time stands still. The possibilities are as limitless as the universes themselves. This theory has profound implications on our understanding of time. It suggests that time is not a linear entity, but a multidimensional one. Each universe, with its unique timeline, adds another layer, another dimension to time. And within each of these timelines, time could loop in its own unique way. A loop here might be a spiral elsewhere, a circle in another, and so on. So, if the multiverse theory holds true, then our understanding of time as a single, linear progression from past to future could be fundamentally flawed. We might need to imagine time as a vast, multidimensional entity, teeming with infinite loops and spirals, each unique to their own universe. In the multiverse, time is not a single thread but a vast tapestry of timelines, each looping in their own unique pattern. From eternal recurrence to quantum superpositions and multiverses, these theories present a fascinating new way to perceive time. We've delved into the Groundhog Day scenario, considered the implications of quantum superposition, and ventured into the vast possibilities of the multiverse theory. Each offers a unique perspective on time, shaking our understanding of reality to its core. As we continue to explore these theories, one thing is clear. Our understanding of time and reality is anything but fixed. So, the next time you check your watch, consider this. What is time, really?